start the session. Yes, in today's class we are going to discuss about Unit 1 revision and today problems in Institute classroom. Right? Let us see one by one. So at the end of this session, you will be able to learn all these facts pertaining to problems in the certain topics and areas. Right? We are not going to discuss any of the problems effectively throughout this session. Right? We are going to have problems with respect to these topics, right? So first of all, you know about energy equation, right? What is your energy equation? Energy equation is H naught is equal to H plus T square by 2, right? Everybody knows this. Using this energy equation only, this stagnation state, the critical state and the critical Mach number, all these things have been derived, right? That is this velocity of sound, the Mach number, and then various flow regimes. Okay, we are going to derive only with this equation, right? And the other equation is from energy equation. We have the substitution of speed of sound. So A naught square divided by gamma minus 1 is equal to A square divided by gamma minus 1 plus C square divided by 2, right? And then we have the other expression called C max square divided by 2. Right? And then if we substitute for critical states and all, okay, if we substitute A square and C square as A star square, that is A and C is A star square, that is the critical state. A and C is equal to A star, and then the same equation becomes A naught square by gamma minus 1 is equal to A star square A star square into gamma plus 1 divided by 2 into gamma minus 1 is equal to C max square by 2, right? And this is always said to be the H. So your H naught may be in any form, right? Because critical state also the total energy is said to be constant, and then maximum energy, maximum enthalpy gain is that you can see square max by 2. It is also known to stagnation. And then you know about stagnation states also. So, for example, if you are going to use this relation, it is nothing but 1 plus gamma minus 1 divided by 2 whole square, right? And these equations are said to be the important equations. You should always remember. And then velocity of sound, right? Velocity of sound is A is equal to root of gamma. Right, and then Mach number you know very well, M is equal to C by E, so flow speed by sound speed. So all these things are there, right? So utilization of all these equations in this tutorial problem is coming, right? We will solve the problem accordingly and then we will get the solution for this, right? So let us see one by one. So this is problem number 1. In total we are going to discuss 5 problems, and this is your problem number 1. Okay, the pressure and the temperature. The pressure, temperature and the Mach number, right? Pressure, temperature and the Mach number at the area of the flow passage, okay, are 2.4 bar L, 26.5 degrees Celsius and 1.4 SPM. So pressure, temperature and the if the exit Mach number, we are having the exit Mach number as 2.5, right? It increases. And then determine for adiabatic flow of a surface. So we have to determine certain parameters from adiabatic flow property. So that is, you have to find stagnation temperature, you have to find temperature and plus C, and then you have to find a flow rate per square meter in the inlet cross section, right? So all these things are there. So we are going to evaluate step by step now. So I need answers from your students. That is, we have to write the given data first, right? This given data, right? So what I said, we know about the entry flow passage. So if we consider this is a flow passage. We have the entry section, section 1, and the exit section, section 2, right? So this entry flow passage properties are P1. So P1 is 2.45 bar, right? And then you have T1, right? Temperature T1. What is temperature? 26.5 degrees Celsius. So you have to add with 273 get Kelvin. So what is the answer? What is the temperature now? Yes, 299.5 Kelvin, right? So this is your temperature T1, and we have Mach number M. And then we have the exit Mach number, right? So my exit Mach number M2 becomes as 2.5, right? Now listen to the problem. You have to, what you have to find, and we know that formula. So that is this. Okay, so the problem asked is to find stagnation temperature. So for finding stagnation temperature, that is T0, you have to find T0. So in order to find the value of T0, I have been told you that T0 by T relation is equal to T0, because you know the Mach number. Okay, my Mach number is 2.5, and then the state is said to be added. So what happens? Then your stagnation temperature is said to be constant. So your T01 as well as T02 is said to be T0, right? And then you are going to use any of the relation, that is T0 by T relation, but you know the value of T1, right? So the value of T1. So using the T1, you could estimate the value of T1. Okay. And then we have to find the temperature and the velocity of gas at phase. So temperature and the velocity of the gas at phase. We have only the Mach number of phase. We have to find the temperature of the gas, that is T0, T2, and then velocity of gas at phase. It means you have to find the velocity of gas, that is C2, right? So you have to find what T2 of the C2, right? And then the flow rate per square meter of the inlet process. This is m dot by V, right? So you have to find what is m dot by V. This is something like flow rate per square meter, right? So we will have some workout now, right? So first of all, we are going to solve for stagnation temperature, right? So stagnation temperature T0. So I have been told you, since the flow is said to be adiabatic, T01, T02 is said to be T0. This stagnation temperature is constant. And then you are going to use this T0 by T relation, that is Mach number relation, plus gamma relation divided by M1 square, right? So T01 by. So you are going to find stagnation temperature now. It's very simple. You just substitute the value of 1 plus what is your value of gamma? Gamma here given is 1.3. Gamma is 1.3. And then what is your R? R is also 0.469 kilojoule per kilogram. So write down all those values in the given potential, and then you substitute after. So it was nothing but 0.3 divided by 2, and then what is your Mach number M1? M1 is 1.4, right? Whole square, right? And then we have T01 divided by your denominator is T1, right? So what is your T1? T1 in Kelvin is 299.5, right? So 299.5, right? Now estimate the value of T01. Yes, very good. Sebastian is very fast in answering. Very good. Yeah, it was T01 is 388, right? Yeah, second time you are also good. That's good. Okay. So this is your T0, right? Now we are going to solve for this T01 and the T02 and the T0 all are said to be the stagnation temperature, and it is constant. 388 is the constant. And then we are going to find the temperature and the velocity at the exit. That means we are going to find T2 or the C2, right? So we will see. So here we are going to find second one, T2 and the C2. So we are going to find T2 and the C2. So in this, what we are going to do is, we have T02 by T2 1, right? So what is that formula? 1 plus gamma minus 1 divided by 2, right? So you know the value of into everything is such a subject, and then you don't know T2, so okay, you can rearrange this formula like this. So T2 is equal to, what is your T0? T0 is T88, right? So divided by plus, right, gamma minus 1 is 0.3 divided by 2, and then what is your into? Into is 2.3, right? 2.5 whole square. Okay, and find the value of T2 now. Find the value of T2 now. What is the value of T2? T2 is 200.25. Okay, so 200.25 Kelvin. Now we could able to find the value of A2, because in order to find the C2, what is the formula you are going to use? So C2 is equal to M2 into A2, right? And then what is your A2? Just substitute the value of M2, 2.5, multiplied by your A2 is root of gamma RT. So your gamma is here 1.3, right? And then your R is said to be 469. Okay, you have to substitute what? 469, that is into 1000. Since the unit is in kilojoule per kilogram Kelvin, you have to convert it to joule per kilogram Kelvin, right? So multiplied by, and then T2. What is T2? 200 point, right? Now estimate the value of C2. Yeah, very good, very good. Great answers from Sebastian and Vagrant. So Vivekanand, I just have some trial and workout the value of C2. It's not a finite, it's about 873. Yeah. The exact answer is 873.54, right? Meter per second is the velocity, right? So we have found the velocity now, and then we are going to find next one, the flow rate per square meter of the inlet cross section, right? So next we will see the flow rate per square meter. It is section 3. We are going to find m dot by A, right? So this m dot by A is nothing but rho 1 C1, right? So rho CA is nothing but mass flow rate. Here they have mentioned only the inlet cross section, so you are going to find only the m dot by A in the inlet. So inlet condition is 1, so rho 1 C1. For this you have to find the rho 1 node, right? So for rho 1 you are going to use the perfect gas equation. Okay, so what is your perfect gas equation? P is equal to rho R, right? So P1, rho 1, R is constant, and T1, right? So what is rho 1 now? So rho 1 is equal to P1 by RT, right? We just take this value and the substitute, right? So what is the m dot A now? So m dot by A is equal to P1 by RT1 into C1, right? And then you know the value of P1, right? P1 is going in the problem. It was 2.45 bar. So you have to convert the bar into Newton per meter square, that is Pascal, right? So conversion of bar into Newton per second is nothing but 2 10 to the power of 4, right? You have to multiply. Please remember this step, because don't substitute the value in bar directly. Just having the value of R as joule per kilogram Kelvin, temperature as Kelvin, and then C as meter per second, so that you have to convert the pressure in meters, right? So not in meters, that is Newton per meter square. Okay, so in order to convert in meter units, you are going to convert this into Newton, and then your C1, right? So you have to find the C1. Still there is some problem with the C1. So for C1 we are having to, we have to substitute the value of C1 as M1 times, right? M1 times square root of gamma r given, right? So directly you are substituting the formula and then r. What is your r? R is 460, right? And then temperature T1. So temperature T1 is 299.5, right? So again substituting all the values. So into M1. So what is your Mach number now? Mach number is 1.4 into square root of gamma value is 1.3, R value is 469, right? Into T1. So what is your T1? So into 299.5, right? So divided by 469 into 299.5, right? Now what is the answer of mass flow rate? Yes. Only Sebastian Bhagirath stands still. Great. So 1043.47 meter per second. Not meter per second, and the unit is kilogram per meter square second. Right. So this is your mass flow rate per square meter. Right. So this is the way you have to solve it. Right. So I think you should be able to understand the problem. This kind of problem ask in your university examination. So and it is available in question bank. I will also post the question bank in the UNS. Okay. Next we are going to discuss about this problem 2. Okay. Our tutorial problem 2 is air. That is Cp value is given, gamma value is given, at P1 pressure is given, temperature is given, the velocity C1 is also given in a 30 centimeter diameter. We have to find what? Mass flow rate, that is in the stagnation temperature. Stagnation temperature means that is T0, and then Mach number. So Mach number means Mach number of the flow, and then stagnation pressure. That is also for stagnation pressure. They are asking two different regions. That is, as a compressible flow, you have to give, as an incompressible flow, you have to. For compressible flow, you are stating that air has been treated as an adiabatic perfect gas. So adiabatic perfect gas, you are solving. It's simple. But in stagnation pressure for incompressible flow, you are considering Bernoulli's equation. And you are going to solve. And finally, we have the point called the Propulsion number, right? So, Propulsion number is nothing but flow speed by maximum speed, right? Flow speed by maximum speed. We can also find the Propulsion, right? So, it's very simple. Don't think that we are having the major data. You have to find the major unknown data, right? It is very simple that we could be able to simplify all these things in a proper way, right? So let us see one by one, right? We are going to find the value of mass flow rate. So for that, we write the given data. Write the given data of the problem. So in this given data, we have the value of Cp. So it was 1005 joule per kilogram, right? And then gamma is 1.4, and the P1 is equal to 5 bar. Maybe you want to convert it as Newton per meter square, so into 10 to the power of 5 Newton per meter. Okay. The T1 is already given in Kelvin, for conversion needed 400 Kelvin, and then velocity C1. The C1 is also given. It was 200 meter per second, right? And then diameter of the gun, right? Diameter of the gun. So D is nothing but 30 centimeters. So 30 minus 2 meters. Right? Yeah, Sebastian is advanced in giving the answers. So what is the area? So from the given data itself, you can find the value of the area. So what is your area? Area is 5 by 4 t square. So 5 by 4 is let's substitute here. So 5 by 4 into So that is 30 into 10 to the power of minus 2 whole square. Right? The area is 0.0706 meters square. Right? I think everybody is getting this answer, right? So after that, we have to find mass flow rate. So what is that mass flow rate? Formula for mass flow rate is O1 C1 A, right? So you know the value of A. We have to find what O1. So in order to find the value of O1, what is the formula we are going to use? P1 divided by R2. Since you know the value of P1 R and P1, right? Still we have to estimate the value of properly. So we have to do some steps here. So for evaluating R, right? So we have CP. So R is nothing but CP minus CP, right? Everybody knows it. And then from this R, CP minus the CV is nothing but CP by gamma, right? So CP by gamma, because gamma is nothing but CP by CP, right? Gamma is equal to CP by CP. And then what is CV? CV is equal to CP by gamma, correct? So what is your CP? You know the value of CP now. So it is 1005. Then 1 minus 1 divided by gamma. Gamma is 1.5. So I'll substitute this. What is the value of R? What is the value of R? Need answers? You can post me in the chat box. What is the value of R? Yes, R is 287.14, right? So 287.14 joule per kilogram. That is the value of R. And now you could be able to substitute this formula, right? So that is P1 C1 A divided by R2, right? We just substitute all of the formulas. So P1 is 5 into 10 to the power of 5, right? And then C1, so C1 is 200 meters per second, and then area is 0.0706, right, divided by R is 287.14 multiplied by temperature T1 is 400. So what is the value of mass flow rate? Yes, it was 61.54. Yeah, 61.54 or 61.46. So I can't be able to assume R value. No, the thing is, they have given CP and the gamma means. If they given the value of R directly, we can take it. If it is R is not available, means they are giving CP value. CP value is giving. You have to remember this. So this is the step you have been studying in thermodynamics, right? So you have to follow this thermodynamics rule, and then you have to evaluate your formula. Okay, because the value of CP may be different for different cases, right? So that is right. And then after evaluating that, so you have to calculate the value of that. And then we have to find the value of stagnation temperature, that is P. Next we are going to evaluate the stagnation temperature, that is T. Right? So in order to find the value of stagnation temperature, we are going to use the value of T0 by T is equal to 1 plus gamma minus 1 divided by 2 m square, correct? Right. So you may use this formula and you can find the value, right? So in order to find this value of m, so m is nothing but C by E, right? So what is your C? C is already given, that was 200 meter per second, and then square root of gamma RT, right? So gamma is 1.4, and then R is 287.14, right? So 287.14 into T. So what is your T? T1 is 400, right? So in all suffixes, we just add this, right? 1, suffix 1, right? And then what is it? Yeah, M1 is 0.498. Yes, 0.498. Yes, we have find the value of M1. Now you can use the value of T1. That is T0 is equal to 1 plus gamma minus 1 divided by 2 is 0.2 into M1 square. So 0.498 whole square, right? Multiplied by T1. So T1 is 400, right? Now what is the value of stagnation temperature? Uh, 439.3. So 439.93. Right? So we had estimated the value of stagnation temperature. Now you have to find the value of Mach number. So we had already find the value of Mach number. That is part C has been completed. While evaluating part B, we had completed the value of part C. Right? Now we have to find the value of stagnation pressure. Right? Now we are going for part B. Stagnation pressure. Okay, so stagnation pressure, compressible. First we are going to evaluate stagnation pressure for compressible flow. So for this, we are going to use this relation. T0 by T is equal to T0 by T gamma by gamma minus 1, right? So on using this relation, we could be able to find the value of stagnation pressure simply, right? So your T0 is 439.9 Kelvin, and then your T is 400, right? Gamma by gamma minus 1. So 1.4 by 0. Right? Multiplied by pressure. So what is your pressure? Was 5 into 10 to the power of 9. So put fix 1 in orbitals. Right? So what is your P01 now? What is the value of P01? Yeah, I need into 10 to the power of 5. Yes, 6.97 into 10 to the power of 5. Okay. So 6.97 into 10 to the power of 5 Newton per meter square. Right? So this is your stagnation pressure. So we had find the value of stagnation pressure with respect to compressible flow. But with respect to incompressible flow, you have to use Bernoulli's equation, right? So your next case is stagnation pressure incompressible. Incompressible. Right? For incompressible, the stagnation pressure P01 is nothing but P1 plus half O1 C1 square. What is this? This is nothing but Bernoulli's equation. Right? So it is valid only under incompressible flow, right? And then you know the value of P1, that is 5 into 10 to the power of 5 plus 1 by 2 to rho 1. So what is your rho 1? So here, at initial case, we have find the value of rho 1. Yes, rho 1 is equal to P1 divided by RT, right? So P1 by RT1 is the same relation. So So P1 divided by RT1 multiplied by C1 square, right? So 5 into 10 to the power of 5 plus 1 by 2 into P1 is 5 into 10 to the power of 5 divided by R. R is 287.14. T1 is given 400, right? Multiplied by C1 square, right? So C1 is 200 whole square. Now, what is the value of P naught 1? Let's need answers. What is the value of P naught 1? Need the answers into 10 to the power of 5, e power 5. What is the exact answer? 5.87, correct? Correct. So 5.87 into 10 to the power of 5 Newton per meter square, right? Value of P naught. See, if we treat the flow as an incompressible flow, then the value is 5.87 into 10 power 5. But if we are treating this as a compressible flow, we are having the greater value, that is 6.97. Since you are treating the air as a perfect gas, right? Now you have to find the E, that is Propulsion number. Okay, we are going to find Propulsion number. Yeah, there is no issue. We can also use it in bar. Yes. Is no issue. Propulsion number. So the Propulsion number is nothing but CR. Right? It is nothing but C divided by C max. Yes. So Propulsion number is nothing but C divided by C max. Right? Then we have to find the C max now. So in order to find the value of C max, we are going to use this formula: C max square by T is equal to A square by gamma max. C1 square divided by, right? Use this formula to find the value of C max. Okay. So what is your A1? So 2 into A1 is speed of sound with respect to A1 is root of gamma R. So A1 square is gamma R, right? So A1 square is nothing but gamma R T1. Okay, so divided by gamma minus plus C1 square by 2. Okay, and then C max taking square root, you are getting this answer, right? So here you may substitute all the values now. So 2 into gamma is 1.4, 287.14 to T1. Okay, so T1 is 400, right? Divided by 0.4, right? And then plus C1 square. Okay, so what is your C1? That is 200 square. So that is, right? So what is the value of C max? Need answers from you. Evaluate and tell me. What's the answer in the chat box? Yes, it was 91.69. So both are having the same answer now. Very good. Great. So it was 918.69. And then what is C? C given is 200 meter per second. And then C max is 918.69. Right? So what is the value of Propulsion number? Yes, it was 0.21. Okay, 217. Right? So Propulsion number is 0.217. So we had estimated all the conditions. So all the formulas are very simple. Don't be afraid of this. Okay. You had to learn all the basic things. So using this, you can simply evaluate all these things, right? See, this is an important 16-mark question, but the thing is, how long we are getting evaluated. We have the very good discussion. That is, we need at least 15 minutes to solve this. Right? The thing is, you should know the background of the problem. If you know the background of the problem, any sense. Right? Now we are going to discuss about problem 3. Right? So an air jet at 400 Kelvin has a sonic velocity. So the mean is sonic velocity, that is they are telling that A star, right? So U is equal to A is equal to A star, C is equal to A is equal to A star, right? Now we have to determine velocity of sound at 400 Kelvin, and then velocity of sound at stagnation condition, and then maximum velocity of jet, right? C max, and then stagnation enthalpy H naught, and then propulsion. So we are going to solve all these things with the help of energy equation. So you have to remember that energy equation, right? In the last problem also we are using that equation, and we had evaluated C max. Here is also we are going to evaluate C max, and then we have the stagnation enthalpy. If we find the value of C max square by 2 will be your maximum velocity square by 2. We act as your stagnation enthalpy H, and then Procor number. Right? So the following parameters are there, step-by-step calculation. So we have to find the new thing, and from the new thing we have the other new thing. So we are finding it step-by-step. So let us see, evaluate step-by-step. Okay. First write the given data. So what is it? We have the only thing P equal to 400 Kelvin, and then they have been telling that sonic velocity. So C is equal to A is equal to A star, right? And then we have to find the velocity of sound. Okay, so it's very simple that you may use gamma RT, and then the air is making as a jet here, right? So air is making as a jet here. Since the flow is here, they have not given any of the property, and then you are using this properties. So gamma is equal to 1.4, R is equal to 287 joule per kilogram Kelvin, right? So for gamma and R, you are taking this value, and then you are going to find step-by-step evaluation. So what is A? So A is nothing but velocity of sound. A you have to find. So A is equal to root of gamma RT, and square root of gamma is 1.4, R is 287, and then T. So T is 400. What is the value of T now? Yeah, it was 401.24 or 400.8. So 401.2, right? So this is in meter per second, and let this value be A star, right? So this is nothing but they were telling that an air jet at 400 Kelvin has sonic velocity. So let this will be the value of A star also, right? And then we are going to find value B, right? So B is nothing but velocity of sound at stagnation condition. Okay, that is A. You have to find the value of stagnation condition. So for stagnation condition, A naught square divided by gamma minus 1 equal to, and we may use this A star square. Okay. So A star square into gamma plus 1 divided by 2 into gamma minus 1, right? So this gamma minus 1, all this getting cancelled. You have to find the So A naught is equal to square root of your A star square is 401.24 whole square, right? And then into gamma plus 1, that is 2.4, right? Divided by 2, right? This square root is overall square, right? Now, what is the value of A naught now? Yes, students, you may play in chat box. Yeah, it was 439.5. 439.53 meter per second. Right? So this is the value. That is stagnation velocity. Velocity of sound at the stagnation condition means A naught we have. And then you have to find maximum velocity of it. Correct? Yes. Very good. Very good response from Bhagirath, Sebastian, and Vivekanand. These three were answering. We don't know about the other students' status. If you get the answer, there is no need after replying in the chat box. Otherwise, if you are not getting any answers, you may ask any doubts. Right? Next, we are going to evaluate maximum velocity object. Right? C. Maximum velocity is C max. So for this C max, so C max square by 2 is equal to A naught square divided by gamma minus 1. We just simply use this relation and find the value of C max, right? Is equal to what is your A naught square? So your A naught is 439.5, right? So 439.52 whole square divided by gamma minus 1 is 0.4, right? 2 square, right? So you will find the value of C max. What is your C max? Yes, good. C max is 982, right? So 982.75 percent, right? So this is the value of C max. Right? Now you may find the value of stagnation enthalpy in simple case. So what is stagnation enthalpy? H naught, right? So what is H naught? H naught is equal to C max square by 2, right? You may evaluate by any other formula means, okay? You may evaluate by any other formula. So for H naught, so H naught is equal to C max square is 982.75 whole square divided by 2. What is the value of H naught? Yes, H naught is 482.89, right? So 482.89. Is it correct? You are telling in kilojoule. Vivekananda? Yes. Yes, it is in kilojoule, right? So kilojoule per kilogram, right? So this is your stagnation enthalpy. So 482.8. Okay. So you may also evaluate that. You can use the other formula, A naught square by gamma minus 1 also. You will obtain the same answer, right? And then after evaluating this stagnation enthalpy, at last we have to find Procol number. Okay. Can you tell me the value of Procol number now? So CR is equal to C by C max. Okay. Your C is nothing but velocity of sound, right? Since your C star, all the things are the velocity of sound. So 401 point, what is it? So 401.24, right? Divided by C max. So C max is 982.75, right? Then what is the value of Procol number now? Was 0.408, right? this is the left. So we had solved 3 problems, right? Let me see the another problem, right? Problem number 4. It's very simple that now you are having some clear-cut idea in solving all these problems, right? So an aircraft flies at 800 km per hour at an altitude of 10,000 meters. Right? So you have to convert this velocity of the air as aircraft as 800 km per hour. So convert it into meter per second, right? And then temperature is given, pressure is given. The air is reversibly compressed in an inlet diffuser. So here the case is we had to solve the duct, okay, previous case. Likewise, here is also we have the diffuser duct. If the Mach number at the exit of the diffuser, so they have given the Mach number at the exit, that is very good. We have to find the value of M1. So in order to find the value of M1, think of plan execute the value of finding the value of M1. Then velocity at the diffuser exit. Right, so velocity at diffuser exit is very simple that we could evaluate, and then pressure of air diffuser exit, that is we have to find P2, right, C2, M1, and then temperature of the exit diffuser T2. Right, it's very simple that. So we have to find the entry Mach number M1. Right, so in order to find M1, what you need? We know the formula. So C1 divided by A1. Yes, fluid velocity. That what is the fluid velocity? That is you had been converting. Okay, that is C1. So C1 is in 800 km per hour. Okay. In order to convert it into meter per second, so 800 into 1000 by 3600. Okay, then it's in 222.2 meter per second. Right, so just substitute the value here, and you could also find the value of speed of sound, A1. So A1 is equal to root of gamma r T1, right? So root of gamma is given. No, it is an aircraft only. So gamma is taken as 1.4. This is 287 multiplied by T1. So what is your T1 here? 223. Right. Now find the value of A1. So what is your A1? So A1 is 299.3. Okay, so find the value of A1. So C1 by A1. Both are said to be a rational number. Then what is your M1 now? What is the Mach number now? Ah, 0.742. So 0.742 is the entry Mach we had estimated. Right? Now you have to find the value of velocity at the diffuser exit. Right? So in order to find velocity at the diffuser exit, what you have to find? So this is velocity at the diffuser exit. So C2. So you have to find the value of C2. Yes, using M2 we can find. So M2 is equal to C2 by A2. So for A2 we have to find the value of T2, right? Okay, so we have to find the value of T2. So in order to find the value of T2, what you have to use is you are going to find T0 by T1 relation. That is 1 plus gamma minus 1 divided by 2 M1 square. Right, using this you are going to find the value of T0, and then again you are going for T0 by T2 relation, and then you are going with the same formula where suffix is different. Right, so 1 plus gamma minus 1 0.4 0.2 and then M1 square. What is your M1 square? Mach number is 0.742 whole square, right, into T1. So T1 is 222. Now find the value of stagnation velocity, stagnation temperature, T0. What is T0 now? Yeah, it was 247.5. Right, now substitute the value of 247.55 here. So we have to find T2 low, right? So T2 is equal to 247.55 divided by 1 plus gamma minus 1 0.2, and then your Mach number is, so I had been evaluating for problem 4. Sorry, students. Yeah, we'll go for it, right? So what is the value of T2 now? Yes, very good. So 247.55 T0 divided by 1 plus gamma minus 1 plus 0.2 into what? M1. Okay, so M2 is 0.36, right? So 0.36 whole square. Right, on evaluating this, what is the value of T2? T2 is 241.2. Right? So 241.2. Right? So after this, we could able to find the value of what? That is M2, right? So what is M2 now? So M2 is equal to C2 that is we have to evaluate C2 now. So C2 is equal to M2 root of gamma r, right? So what is your M2? 0.36 into square root of gamma is 1.4 87 241. That is the value of T2. What is the value of C2? So C2 is 112.09 meter per second. Very good, Bhadrath. So we had find the value of exit velocity of the diffuser. Now we have to find the pressure of air diffuser. Right? We have to find the value of pressure. So it's very simple. So for finding the pressure at the exit of the diffuser P2, again we are going to use this relation. That is in order to find the value of P2, okay, you are going to use the same relation like P01 by P1 is equal to P01 by P1 whole to the power of gamma by gamma minus 1, and then P02 divided by P2 is equal to P02 divided by P2 whole to the power of gamma by gamma minus 1, right? So estimate these two ratios. So you know the value of T01. So T01 is 247.5. So 247.55 divided by T1, right? So what is your T1? T1 is 222, right? Gamma by gamma minus 1. So 0.4 divided by 1.4. So find the value of P01 by P1 now, and then find the value of P02 by P1. Same thing. Okay, 247.55. Temperature, total temperature is set to be constant. So divided by, and then T2. So what is your value of T2? 241.2. All to the power of 0.4. Sorry, it was 1.4 by 0. 0.4 by 0.4. This also 1.4 by 0.8, right? Now find the value of P01 by P1. Yes, because P01 by P1 is 1.09371. What is this ratio? P02 by P1. What is the value? 1.411. 1.441. And what is P naught 2 by P2? So 247.55 by 241.2 whole to the power of 1.4505. Yes, this is correct. Yes, 1.095. Now you have to find P2. So we are going to evaluate P2. You are dividing for these terms. Okay, is 0.451 by 0.09. Dividing this, what we get, and then multiply with P1. Right? So you are getting the value of P2 as into P2. So P1 is 0.27. 0.265. 0.265. And the value of P2 is 1. Yes, it was 0.347. The process of diffuser is that you have to increase the pressure. So the pressure at the exit of the diffuser is increased. Right? No, it was 0.347. Sebastian, check with your answer. Yes. So we had find the value of pressure of air diffuser exit and then temperature of air diffuser exit at T, section T, has already been evaluated. So, yes, it was 0.347. Right? So we had find the value of temperature of air diffuser exit, that is T2 we had already evaluated, then P2 is already. Right? I think now you got to understand the problem solving technique. It's very simple that we could able to solve all the sums in a few minutes. So in total 4 problems we have solved this session. All are simple questions which are sticking with your question, right? And problem number 5 is that, right, you could try on your own. You are free. So kindly note down the problem or make a snapshot and tell me yes. And then you can evaluate and you can show the answers in screen. That is, you can make photographs and then you can share your screen and show the answer. By next class, I will ask you. And then we will go for the food. And then we will go for done. Good. Only Bhagarat and done. What about remaining others? Have you noted the problem? Yeah, okay. It's time up. We will end the class. It's very interesting. Yeah, Sebastian. I will share in groups and voices. Okay. Thank you, Sebastian. Only you 3 people were very sincerely working with our problem. This extendance is going to be the very interesting subject, very deeply involved in research and mathematics. We find that we are not going into a deep optimization and optimization with respect to flow dynamics and flow parameters. We are roughly estimating the one-dimensional flow. We go for 2-dimensional and 3-dimensional. It's to be the very big interesting thing. But the thing is, we need 2 or 3 hours to solve the 2-dimensional problem and the 3-dimensional problem in time. So that we are going for fluid dynamics, computational fluid dynamics. So this is how the computation software were born, right? Okay, thank you all students. I'm going to end the session now. Thank you all.